So section 10.3.1, graphing exponential functions. So keep in mind the following from the previous units. Every point in the input-output table is a solution to the equation, and every solution to the equation is on the graph of that equation. So we're going to start with an input-output table of points to connect to make a graph. So let's look at the table from the previous set of notes for the function y of x equals 3 times 2 to the x. So again, this is in our form, so we had our definition for an exponential function was f of x equals a times b to the x. Okay, so we have that form here. Okay, so we've got an exponential function. So we should notice first off over here that our inputs here keep increasing by 1, -3, -2, -1, 0, 1, 2, 3. And our outputs here to get from 3 to 6 to 12 to 24 keep doubling, keep multiplying by 2. Okay, so if in this direction we need to multiply by 2, in the opposite direction we need to divide by 2. So we're going to, and again I'm going to keep them as fractions, so we'll get 3 halves, divided by 2 we'll get 3/4, divided by 2 we'll get 3/8. So part 8 says to use the pattern in the table to fill in the rest of the output values. So we just did that. So now we're asked to graph the ordered pairs from the table. Okay, so if we take a look at the initial ones that were given, we had a point at 0, 3. Okay, so this will be our y-intercept. And then we had a point at 1, 6, and another one at 2, 12. Okay, so kind of off our screen here, 11, 12. And then again 3 and another one that was way up there at 324. And then in the other direction we found that at -1 we had 1.5. Okay. And then at -2 we had 3/4 and so on. Okay, -3 we had 3/8, and then half of that and half of that and so on. So we get this graph. It's kind of different from the linear and quadratic ones that we've seen. So as the input values become more and more negative, what happens to the output values? Okay, so if we're looking in our table, as these outputs became more and more negative, our outputs became, we kept dividing by 2. We kept getting half as much as what we had before. And so if we take half of this, we're going to get 3/16, and then 3/32, and 3/64, and so on. Okay, so the question asks us if that output is ever going to reach 0 in this direction of the graph. And the answer to that is no. Okay, so as the input, what happens to the output values? Okay, they keep becoming half of what they were. Oops. Half of what they were. And again, if we keep taking a number and taking half of it and half of it and half of it, so we asked, will the output, I should say ever, reach 0 in this direction of the graph? And the answer to that question is no. Okay, so we keep taking half of the number and half of the number, okay, we're still going to have something left. Okay, we're never going to reach 0 in this direction of the graph. So then we're asked, as the input values become more and more positive, what happens to the output values? So again, if we go back up and look at our table, as we became more and more positive, 3, 6, 12, I'm sorry, inputs, 0, 1, 2, 3, as they were becoming more positive, if we look at our outputs, they kept doubling. All right, so as the input values become more and more positive, what happens to the output values? In this case, they keep doubling. So our table ended at 24, and if we double, we'll get 48, and if we double again, we'll get 96, and so on. And so again, we're asked, will the output ever reach 0 in this direction of the graph? And the answer to that question is also no. Okay, so in this case, as we're looking at the graph, there are not going to be any x-intercepts. In this direction, we keep becoming half as much as what we were, and in the positive direction we keep having our values double. Okay, this graph is never going to cross our x-axis. All right, so now consider the following function. So again, we should recognize that we have yet again another exponential function. Okay, this is in the form f of x equals b times a to the x. Okay, where a is greater than 0 and a is not 1. Okay, so in this case b is 4 and our a is, or actually we use, let's get this, a times b to the x. Not that it matters, but so that this matches what we've seen in the previous section, where that base multiplier has to be greater than 0, and that base cannot be 1. Okay. So again, in this direction, as we're looking at our numbers, to get from 4 to 2 to 1, we keep dividing by 2, which means in this direction we need to multiply by 2. So we're going to get 8, 16, 32. Such that all the way down the column here, we can think about either dividing by 2 or multiplying by half this base multiplier that we have in the exponential function. Okay, so 32, half of 32 is 16, half of that is 8, half of that's 4, 2, 1, and finally here we would get 1/2. So again, if we graph the ordered pairs from this table, again, we had our initial value, our y-intercept here at 0, 4. And then for 1, our output was 2. And at 2, our output was 1. And again, in this direction, they keep becoming half as much as what they were before. So we get a graph, and oops, kind of missed the dots there. In this direction that looks like this, and again it's going to keep becoming half as much as what it was. It's never going to actually reach 0 and cross through this axis. And then in the other direction, at -1 we had an output of 8, and at -2 we had an output somewhere way up here at 16, and so on. And that's going to extend indefinitely in that direction. So now as the input values become more and more negative, so in here, our inputs are becoming more negative in this direction. And if we look at what's happening to our outputs, they keep doubling. So what happens to the output values? They keep doubling. And so again, if we keep doubling the number, are we ever going to reach 0? And the answer is no. Okay, so what happens now is we're getting more and more positive instead. So if we go up to the table, so our inputs in this direction are getting more positive. And if we look at our output values, they keep dividing by 2, becoming half as much. So what happens to the output values? They keep becoming half as much. So again, you start with a number and take half of that, and half of that, and half of that. It keeps getting smaller and smaller, but it's never going to actually reach 0. Okay, so these curves will not have any x-intercepts. Okay, so this graph that we've drawn here is called an exponential curve. So this is just the shape of the graph of an exponential function. And from the previous section, an exponential function is of the form f of x equals a times b to the x, where again that base multiplier has to be greater than 0, and it cannot be 1.